Welcome! In this video I'm going to explain one vulnerability in the code you saw in the last video. If you haven't seen that, definitely take a look at the video and play around with the code by yourself first. There are links to both in the video notes below. You were looking for an XSS in some code that uses HTML backtick to generate a string of HTML. There are a few dodgy bits of code. First, the escape function doesn't escape all HTML meta characters. Second, the HTML function has some complex regular expression logic that disables escaping. Third, the strip tag function uses regular expressions to parse HTML. Fourth, there's some application logic that has special handling for some accounts. This gives you a lot of places to look for a problem. But if you didn't find any problems, don't feel bad. This was meant to be pretty subtle. I'm going to show you one problem. If you found others though, please let me know in the comments. One big red flag if I was reviewing this would be the way two different bits of logic deal with legacy user ID. Legacy user ID is accessed here, and it's accessed separately here. This feeds into the code that lets me render a legacy user's name with colorful HTML. That works because down here, the template uses the double $ form to avoid escaping. It checks is legacy user, and if it's a legacy user, it applies an identity escaping function. Otherwise, it applies strip tags. Normally, the result of $curly is escaped. So I can demonstrate this by calling HTML directly. So HTML backtick with $curly and inside it a string that has some HTML tags produces a string with HTML tags escaped. But if I add a second $ to it, it comes through unescaped. So this double $ is legacy user bit checks whether legacy user ID is a legacy user, and if so, lets it through unescaped. This seems safe because up here, proper noun 1 is a string from a lookup table when legacy user ID keys into that table. So when might is legacy user return true, but proper noun 1 not be a value from that lookup table? Notice that the first assignment to legacy user ID uses a plus sign to convert to a number, but there's no plus sign down here. I can pass a string for legacy user ID. So I'll just add quotes. If I pass a different string that courses to the same number, the render function doesn't find the value in the lookup table. So now it says, dear you. And I can fit a payload in proper noun 1. So I'm going to put a script tag that shows that I can reach into the parent frame and grab a value. And you see an alert. The author wanted to treat some values as privileged. The HTML strings and legacy names should be exempt from escaping, but input.properNoun should not. The underlying problem here is that privilege is not granted based on the nature of the value. The HTML function decides how much escaping to do based on whether there are two $ in the template. As in this example, the code that decides what value to use can be out of sync with the code that decides whether to treat the value as privileged. This is a contrived example, but lots of legacy code has similar problems. Legacy code accumulates bugs, and since it's legacy code, there are rarely enough resources to find and fix them. We need to make sure that these bugs do not compromise security. In the next video, I'll discuss the underlying problems behind the three puzzlers. I'm going to argue that even though each has a different kind of vulnerability, there are common threads. I hope to convince you that we can have the benefit of highly dynamic languages while producing secure systems. If you want to avoid these problems in your code, use a strict contextually auto-escaping template system. I wrote the HTML template language in this example to demonstrate a problem, and it should not be used in production because it does not handle JavaScript URLs and attributes, among other problems. Thanks for watching!